Let's look at how C strings are used. The string class in C++ is very different than C strings. C strings are just arrays of characters that are terminated by a null character. So if you see the sequence in double quotation marks, hi there, what is going to be in the computer's memory are all the individual letters in an array followed by this null character to let you know that you're at the end of your string in C. So when you define an array to hold a string in C, you have to give it one extra space to hold that null character. So if we have a string that's 20 characters for the city, we can only use 19 characters for that name so that it can hold that null character at the end. We can read into strings, and that input is terminated by the white space. But there's no check to see if there's enough room. So we could start rewriting anything in memory. Now, if you give somebody the opportunity to rewrite anything in memory, you're also giving them the opportunity to hack into your code. So that's not something we want to be doing. If you want to control the amount of input, you can use the cin getLine, and that has a parameter that allows you to limit the number of characters that are read in. Let's look at an example. Now, first off, the modern C++ compilers do not want you to use these string functions. You have to specifically say to allow it. If I try to compile this program, you can see there are a lot of examples warning me that I'm not managing my strings correctly, and in fact is giving me errors saying that I can't use the string copy method, because it doesn't limit the number of characters, and that is a potential for a hacking and attack on my code. So in order to actually use these old string functions, you have to define that you don't want the warnings. So it's a pretty good warning that you don't want to write any new code that uses these string copies. They're not safe. If you're looking at someone else's code that was written in the past, you may still run into it. If you do run into it, you should replace all string copies with the string n copy to verify the number of characters that you are allowing to be copied. We do want to build this, so let's go ahead and define that we are going to accept that this program is unsecure and that we're going to run it. And let's see what we can do with strings and what kind of trouble we can run into. So here I've defined an array, and because I've assigned it a value immediately, it has given the correct amount of space for that array. And you can see it says it's a const char 2. Why is it 2 characters? It's just one space. Well, remember, we have the space character and then we have the null character after it. We can also assign letters into it, and that looks very similar to using strings in C++, the string class, but it's handled differently because it's just an array in memory with a null terminator. We can also just declare some variables by giving it a particular size, and then there's nothing assigned to it. So if we were to look at that, that would just be garbage right now. Let's go ahead and look at running this program partially. Let's run it through to line 33. So now that I said I'm willing to accept the security risks and go ahead and run it anyway, Visual Studio will comply, and you can see that I was able to use this string copy method, and I copied a string that is a constant string literal and put it into my sum make, and then I was able to write out that sum make. I could also copy my make, which I assigned to be Chevy up here, and assign it into your make, and now your make is also holding Chevy. So we were able to copy a string from the string literal and a string from one character array into another character array. Let's examine those in the debugger. So here you see sum make had Ford copied into it, and you can see it's just those characters right in the array, and then it stops at number 4 and is null terminated, and the rest is just whatever happened to be in there. Some make has room for 10 characters. It's only 10 because the 11th one has to hold that null, but we only put in 4, so the null gets put right after those characters, so that when it gets written out, the output stream knows to stop writing out as soon as it gets to that null character. Let's add a watch to my vehicle. My vehicle was never assigned anything, so it's just junk. If we were to try to write out my vehicle, it wouldn't know where to stop. There's no null character. It would just keep writing from memory until it found a null character somewhere and interpret those things as characters, even though they could be numbers, they could be doubles, they could be code. We don't know. So let's go ahead and try writing that out. We're trying to write out my vehicle. My vehicle is a bunch of garbage, but you can see that it just kept going. And I guess my vehicle just happened to be placed in memory before my model, because it finally hits my model, writes out Camaro, and then finally finds that null terminator. But you don't have control over what memory is going to be used and where it's going to be put, and who knows what you're going to get written out if you do not properly terminate your strings. So let's look at what we wanted to actually do with my vehicle. So we'll get rid of this line that we added in. First, we're going to copy my make into temp, and temp started out as garbage, and we're going to put my make into temp, and my make is properly terminated. And then we're going to concatenate a space to that. So we have Chevy, then we're going to put a space on temp, and then we're going to concatenate the model on there. So we should have Chevy space Camaro in temp. Then if we copy from temp into my vehicle, then we should have that whole string, as long as it fits. So let's put a breakpoint lower down and see if we get our my vehicle printed out properly. And my vehicle has become Chevy Camaro. When we built our string, all the pieces that we used to build up our temporary string were properly terminated with the nulls, and therefore when we did the copies and the concatenations, all the nulls were properly added in. And then we just did a copy of that temp into my vehicle, and since it was properly terminated with the null, it only copied until it found that null character, and our vehicle turned out to be just fine. We can do a string comparison, and if it's less than 0 when we compare two strings, then we know the first is less than the second, and if it's greater than, then we know the first one is greater than the second. And when it's 0, it's equal. So we can actually do comparisons of our C strings. So let's go ahead and jump down and execute that and see our comparisons. So we can see that Chevy is less than Ford because C comes before F in the alphabet.